Welcome to the Future Drive Academy. If you're returning Sabi, welcome back. And if you're new here, please hit the subscribe button to join the online academy. This is a space for education, empowerment, exchange, engagement, and everything academics. In today's video, we're going to go through a trig exam type question step by step. But before we do it together, pause right here and try it. Alright, I believe that you have attempted this question. Now we'll do it together so that you can see how you should have attempted it, what you missed, and how to go about it. So going to the first question, it says, if 7 tan theta is equal to 3, cos theta is less than 0. Use a sketch in the correct quadrant to determine the value of sin theta plus cos theta divided by 2 sin theta without using a calculator. So in order for us to determine that without using a calculator, we need to use the cast diagram, because the cast diagram tells us where each ratio is either positive or negative. But firstly, we have to write our equation first, because they gave us the equation as 7 tan theta is equal to 3. So to write that equation, that means that we're going to have tan theta is equal to 3. To remove 7 on the left hand side, we divide both sides. So it's going to be tan of theta is equal to 3 over 7. Right. And what do we know about the ratio of tan? We know that tan, it is equal to opposite over adjacent. So because tan is equal to opposite over adjacent, that means that our 3 there is our opposite and our 7 there is our adjacent. Right, so now let's go to our cast diagram, and we can also see that we have a positive value there, right? Our tan is positive. So going into our cast diagram, so now going to our cast diagram, tan will be positive only in two places, which is the first quadrant and the third quadrant. That's where tan will be positive, because remember, we have all students take coffee. So that means that in the first quadrant, all the trigonometric ratios are positive. In the second quadrant, only sine is positive. In the third quadrant, only tan is positive. And in the fourth quadrant, only cos is positive. All right, so that means that our diagram will either lie on the first quadrant or the second quadrant. But now they gave us a tip. They said cos of theta should be less than 0. So if cos of theta is less than 0, that means that in the first quadrant, everything is positive, meaning that your cos is positive, your sine is positive, and your tan is positive, right? The only time where cos is negative is in the third and fourth quadrant. But our solution, our tan must be positive, remember? So that means that we can eliminate this area. We can eliminate this part. And that means that our solution will lie in the third quadrant. And we have theta there. So they gave us to say that tan of theta is equal to 3 over 7. So 3 is our opposite. The opposite side of this angle, it is this. And the adjacent side, it is that. So that means that your x is -7 and your y is -3. Whenever you divide these two to say -3 over -7, the minus, they cancel out. Hence, our final answer is just 7 over 3. After correctly identifying where your quadrant should lie in, now the next phase is to answer what the question is actually asking of us. And it says that we should determine sin of theta plus cos of theta divided by 2 sin theta. But there's one problem. We are missing one side in our diagram. We are missing the r. So before you even go into answering what the question is asking for, we need to get all the values in your diagram. So that means we're going to use the theorem of Pythagoras to find the missing side. Our r, that's what we're looking for. Our x is -7 and our y is -3. Right, plug that in the calculator. Let's see what you get. So I get square root of 58, which is our r, so we go and put it there to say square root of 58. Right, so now we can go into answering the question. So the question wants to find the value of sine of theta plus cos of theta all divided by 2 sine theta. In order for us to find the ratios, we're going to use what we call SOHCAHTOA. So SOHCAHTOA is a tip that you can use to remember the ratios, right? So it's like it represents, or it's a summary of your trigonometric ratios, where your S, that's your sine, your C, that is your cos, your T, that is tan. Another tip that you can use is having another hour of algebra, right? Where your O is opposite over hypotenuse, your cos, it is adjacent over hypotenuse, and your tan, it is opposite over adjacent. So that's the quickest way to remember the ratios of your trigonometric equations. So sine of theta, we know that sine of theta is opposite over hypotenuse. So if this is your reference angle there, your opposite side is 3 and your hypotenuse is 58. Cos of theta, so cos of theta, we know that it is adjacent over hypotenuse. So if this is your reference angle, your adjacent side is that side and your hypotenuse side is your square root of 58. All divided by 2 sine theta. So we already have determined the ratio of sine of theta, so we can just say 2 -3 over square root of 58. Then you plug this on your calculator. Let's see what you get. Alternatively, you can work with this step by step. If you don't want to directly use the calculator from here, you first work out what you have in numerator and what you have in your denominator, and then, okay, let's do it that way. Working out the numerator only on my calculator, I get -5 square root of 58 all divided by 29. Gonna divide that by your denominator, which is -3 root of 58 all divided by 29. Then you can divide those two. So dividing both your numerator and denominator on your calculator, you should get 5/3. Now let's go to the second question. Let's read the question. It says, if sine of 32 is equal to P, express each of the following in terms of P. You're given 4.2.1 tan of -32, and the second one sine of 418. Before you even attempt the question, let's draw our diagram. Just like the previous question, we look at the value of 32. In this case, P is positive. And what does that mean? That means that it was sine of 32, which is equal to P divided by 1, where this is your opposite, that is your hypotenuse. And your P is what? It's positive. Sine is only positive in 2 quadrants, which is the first and the second quadrant. So what does that mean? So it means that in this case, our diagram will lie in this quadrant, in the first quadrant, because our angle there, it is less than 90. Right, you have tan of 32. The opposite side is P and your hypotenuse is 1. We're missing a side, which is X. So before you even go into answering the questions, you must ensure that you have all your values in your diagram, your R, your y and your x. So in order for us to find the missing side, we're going to use the theorem of Pythagoras, where r squared is equal to x squared plus y squared. What is our r? It is 1. Our x, that's what we're looking for, and our y is p. Now let's simplify our equation. So when we simplify it, that means that we're going to have x is equal to 1 minus p squared. Right. So remember, the square root gives us 2 solutions, but because our diagram is in the first quadrant, that means that actually our x is going to be positive 1 minus p squared. That's what we put there. Right. Now let's go into answering the questions. Point 1 says tan of negative 32. Tan of negative 32. Here we have a negative angle. Whenever we have negative angles, only cos will be positive. So if you look at your cos of negative theta, it will always be cos of theta. If you have sine of negative theta, it will always be negative sine of theta. And if you have tan of negative theta, you're going to have negative tan of theta. The only one that will be positive is cos. So in this case, because we have negative angle, that means that this is actually equal to negative tan of 32. Right. So we get negative tan of 32. Then how do you go about it? Tan of 32 is what? The ratio of tan, it is opposite over adjacent. So because it's opposite over adjacent, that means that we have to look at the opposite side. What is the opposite side of this angle there? It is your p. And what is the adjacent side is what you have there. So that means that your answer will be negative the ratio of tan 32, it is p over square root of 1 minus p squared. That is your final answer. Right, that's your final answer. So now let's go to the second question. So we have sine of 418. So before we even use the reduction formula to break down that 418, let's find all the angles in our diagram. So we know that there we have 90 degree. Then on the other side, 180 minus 32 minus 90, you get 58. Right. So now let's check. Using the reduction formula, if we say 316 plus 58, we get 418. So that means that for this question, we're going to break down the 418 to be 360 plus 58. Right. 360 plus 58 lies in which quadrant? Remember, all students take coffee. Right. So 360 plus 58 lies in the first quadrant. In the first quadrant, that is where sine is positive. So if sine is positive in the first quadrant, that means that your final answer will be sine of 58. Right. So how do we define sine? Remember, sine is opposite over hypotenuse. Now, our reference angle is 58 there. So your opposite side is what? It is what you have there, square root of 1 minus p squared, and your hypotenuse remains 1. So that means that your ratio will be 1 minus p squared all divided by 1. And your final answer will be 1 minus p squared. Alright, now let's go to the third question, 4.3. It says, simplify the following fully without using a calculator. So that's what we're given. So we're just going to write that. Alright, so that's our equation. So we're going to use the reduction formula in order for us to simplify our equation. Right. So in order for us to use the reduction formula, we need to keep in mind our cast diagram. So our cast diagram, we need to know where our trigonometric ratio is positive or negative. How should we reduce it, right? So looking at the first equation, which is sine of 120. So sine of 120, if we say 90 minus 120, we get 30. So that means that we have sine of 90 plus 30. Sine of 90 plus 30 will give us sine of 120. Right, now going to the next one. Tan. So there we have tan of 300. So tan of 300, we can break it down as 360 minus 60. Because 360 minus 60, we're just going to have 300 all divided by. We have cos of 60. Remember from the previous question, whenever we have negative angles, the only one that changes is cos. So that means that we're going to have positive cos of 60 times tan 225. 225 minus 180, we have 45. So that means that we can break that down as tan of 180 plus 45. We have now simplified our terms. So now let's reduce it. And if you can just check everything that we have, our thetas in this case, which is what we have here, all of our thetas, they represent special angles. So whenever you have to simplify trigonometric equations, you always have to reduce. One of the angles must represent your special angles, the other one must represent your reduction formula angles. So always whenever you have to break down your angles, you'll sometimes need to use special angles. Then now let's simplify. So sine 90 plus 30, that is in the second quadrant. In the second quadrant, sine is positive, but because it's sine of 90, it will change to its co-ratio cos. So we're going to have cos 30 times tan 360 minus 60, that is in the fourth quadrant. In the fourth quadrant, tan is negative. So it's going to be times negative tan of 60, all divided by cos 60 times tan 180 plus 45, that is in the third quadrant. In the third quadrant, tan is positive. Remember, all students take coffee. So in the third quadrant, your tan will be positive. So we write it as tan of 45. Right. Because all the angles that you have as special angles, you can just plug them in the calculator. Cos of 30 will give you root of 3 over 2 times minus tan of 60 will give you just 3, all divided by cos of 60 will give you 1 over 2 times tan of 45 will give you 1. When you plug this in the calculator, you should get your final answer should be negative 3. Now going to the next question, 4.4, we have to prove an identity. So whenever you look at proving identities, you should first look at what your right hand side has. So our right hand side has 1 over tan x minus 1 over sine of x. So that means that whatever that we do, we must make sure that we always have your tan and your sine at the bottom. Left hand side. So our left hand side is equal to, so this is what we have on our left hand side, where cos of square x minus cos x minus sine square x divide by 2 sine x cos x plus sine of x. That is what we have. But looking at our left hand side, we know that we must divide by tan of x and sine of x. So that means that whatever that we do, our goal for the first equation is to ensure that we always have a cos x over sine of x, because this is the same as 1 over tan x. And then for what we have on the other side, we must make sure that we always have sine of x at the bottom, so that whenever we simplify, we can have whatever that we have on our right hand side. This is an identity. Sine square x is an identity, cos square x is an identity, but we have one rule. Either we can change this one to be 1 minus sine square x, or we can change the sign to be 1 minus cos square x. So the best one to change, it is your sign. Why is it sign? Because we don't want to get rid of cos on top, because the cos on top there will give us whatever that we have on our right hand side. So now we're gonna simplify to say that we have cos square x minus cos of x minus 1 minus cos square x, all divided by, so let's see what we can change at the bottom. At the bottom, we cannot change anything for now, but what we can do is to factor out. So we can factor out sine, because sine is a common factor. So we're gonna have sine x 2 cos x plus 1. So whenever you factorize, whenever you multiply back in what you factored out, you must get exactly what you initially had. Simplifying our numerator, it's gonna be cos square x minus cos x minus 1 plus cos square x, all divided by plus 1. Right, let's add your cos square and cos square. Those are like terms, so they're gonna be 2 cos square x minus cos x minus 1, all divided by sine x. We don't want to get rid of that sine x there, because we want something, remember here, that will give us either cos of x over sine of x, so that we can end up with 1 over tan of x. So we're keeping that 2 cos x plus 1. All right, so whatever that we have there on top, it's the same as having 2x squared minus x minus 1, right? So hence we're just gonna factorize it like how we would if we had an algebraic expression. So hence we're now gonna say 2 cos x. If you're struggling with factorizing, you can use the quadratic equation, which is x is equal to negative b plus minus square root of b squared minus 4ac, all divided by 2a. You will be able to get the correct factors, right? Because here our a is 2, our c is negative 1, and our b is also negative 1, right? If you can plug in these values in your algebra, in your quadratic equation, you will be able to get the factors that should come here. All right, this is what we have in your numerator. Your denominator, you still have sine x 2 cos x plus 1. Right, now we can see, we can cancel, because that will cancel out that. What are we gonna be left with? I'm gonna be left with cos x minus 1 over sine of x. All right, now we can separate the two terms. So separating the two terms, that means that we're gonna have cos of x over sine of x minus 1 over sine of x. Now cos x divide by sine of x, this gives you cot of x minus 1 over sine of x. We can write cot x as 1 over tan of x minus 1 over sine of x, because we know that cot of x is equal to 1 over tan of x, and this is equal to what you have on your right hand side. That's how you prove this identity. Thank you guys for watching. If this video helped you in any way, please don't forget to subscribe and join the online academy. I'll be dropping more videos on different topics. I'll leave 4.5 for you guys to do as homework. Please drop down the answers on the comment section below, and let's see who will get it right.